Switch. Imagine you're in a giant cafeteria. Everyone's yelling across tables, trying to pass notes. Total chaos, right? That's what a network would look like without a switch. A switch is like the super strict lunch lady who says, no yelling. If you've got a note for Timmy, hand it to me and I'll give it straight to him. Boom, problem solved. A switch is a device that connects multiple computers, printers, or even gaming consoles inside the same network. It makes sure that information gets sent only to the device that needs it, not blasted to everybody. Think of it like mailing a letter with the exact address instead of shouting it through a megaphone. Older networks used hubs, which were basically the sloppy cousin of switches. They'd just throw your info to everybody and hope for the best. But a switch is smarter. It learns the addresses, MAC addresses, of every device connected to it and delivers data like Amazon Prime shipping, fast and directly to your door. Without switches, your Netflix would buffer forever, your Zoom calls would freeze, and gaming online? Forget it. Switches keep everything running smooth, like the traffic lights of the internet highway. Router. If a switch is the lunch lady, then a router is the school bus driver. Instead of just dealing with kids in one cafeteria, the router's job is to move people between different schools, neighborhoods, or even cities. In networking terms, it connects your local network, like your home Wi-Fi, to the internet, the massive, chaotic world out there. Picture this. You're at home and you want to watch YouTube. Your computer yells, "Hey, I need cat videos, stat!" The router hears you, figures out which road leads to YouTube servers, and drives your request safely there. Then, like a good bus driver, it makes sure the cat videos come back to you, and not to your grandma's iPad by accident. Routers also act like overprotective parents. They don't just let strangers walk in. They'll block random internet weirdos from barging into your Xbox or laptop. They hand out IP addresses too, which is like giving every kid on the bus a seat number so no one gets lost. Without routers, your devices would be screaming into the void with zero chance of finding the websites, games, or apps you need. Basically, routers are your personal tour guides to the internet, gateway. Imagine your network is a tiny town, and the gateway is the giant toll booth on the edge of town. Every car leaving or entering has to stop there. The toll booth worker doesn't just wave people through, they check maps, switch signs into the right language, and sometimes even change the currency so travelers can pay correctly. That's exactly what a gateway does. See, not all networks talk the same way. One might be using one set of rules, protocols, while another uses completely different ones. Without a gateway, they'd look at each other like, what did you just say? The gateway steps in like a translator, making sure the message makes sense on both sides. When your home devices need to reach the internet, the gateway is the first and last stop. Outbound requests, like your PlayStation asking for an online game, pass through it, and inbound traffic, like the game's data, comes back through it too. It's the trusted checkpoint, making sure nothing gets lost or misunderstood. So, while switches and routers handle traffic inside your network, the gateway is the official exit and entry point. Without it, your network would be trapped in its own little bubble. Subnet. Think of a subnet like cutting a giant pizza into slices. Sure, you could just leave it as one huge pie, but then everyone would be grabbing at the same greasy mess. A subnet slices up a big network into smaller, cleaner chunks so things don't get out of control. Let's say your school has 500 computers. If they were all crammed into one giant network, it would be like 500 kids all trying to talk to the same teacher at once, loud, messy, and nobody learning anything. A subnet steps in and says, "Okay, this group of computers is in one slice, that group is in another, and so on." Suddenly, everything's calmer. Subnets also make networks faster. Instead of shouting across the entire building, your computer only has to whisper to its little subnet. Plus, they make things safer because you can wall off certain slices so they don't mess with each other. In real life, businesses use subnets to separate departments. The finance team's traffic stays in one lane, while the gaming on lunch break team, department, stays in another. Without subnets, networks would be one giant screaming match. With them, it's organized like pizza slices, delicious and efficient. Firewall. A firewall is basically the security guard of your network. Picture a big, muscly bouncer standing at the door of a concert. He's checking tickets, tossing out troublemakers, and making sure only the right people get in. That's what a firewall does, except instead of rowdy fans, it's blocking viruses, hackers, and shady data trying to sneak into your computer. Firewalls watch every single piece of information coming in and out of your network. If something looks suspicious, like a stranger knocking on your laptop at 3 a.m., the firewall slams the door shut. It's picky too. You can even tell it what to allow and what to block, kind of like giving your bouncer a VIP list. There are two main kinds: hardware firewalls, like a physical security gate, and software firewalls like a digital bodyguard living inside your computer. Most people use both for double protection. Without a firewall, your network would be like leaving your house unlocked with a giant "free snacks inside" sign. You'd have hackers moving in before dinner. With a firewall, you've got peace of mind and fewer sketchy characters poking around your files. NAT. NAT, short for Network Address Translation, is like the receptionist at a super busy office. Imagine your whole family sharing one phone number. When people call, the receptionist answers and says, "Oh, you want Mum? Hold on, I'll connect you." Or, "You need little brother Timmy?" "Yep, he's available." That's exactly what NAT does for your home network. At home, all your devices, your phone, your laptop, your Xbox, even your smart fridge, share one public IP address. To the outside world, it looks like there's just one number. NAT steps in to keep track of who's who, translating between your private home addresses and that single public one. So when your computer says, "I need YouTube cat videos," NAT remembers, yes, that request came from this device, and makes sure the cat videos get delivered to the right screen, not your fridge. It also adds a layer of security. Strangers on the internet only see your one public address, not the private ones hiding inside. Without NAT, every device would need its own public IP, and we'd run out of numbers faster than kids fighting over the last slice of pizza, DMZ. Nope, we're not talking about a war zone with tanks. In networking, a DMZ stands for Demilitarized Zone. And yes, the name is as dramatic as it sounds. Think of it like a fenced-off backyard between your house and the wild street outside. It's a buffer zone for your network. Here's how it works. Some computers or servers in your network need to be visible to the outside world, like a web server hosting your blog or a game server for your friends. But you don't want strangers snooping around the rest of your private network. That's where the DMZ comes in. The DMZ is like a guest room in your house. Visitors can come in, sit down, maybe grab a soda, but they're not allowed to wander into your bedroom, bathroom, or secret snack drawer. If something shady happens, the damage stays contained in the guest room, not your whole house. It's not totally bulletproof. Bad guys can still cause trouble in the DMZ, but it keeps them away from your main network. Basically, the DMZ says, "You can hang out here, but don't even think about touching my stuff." Port forwarding. Okay, imagine your house has 100 doors, but all of them are locked tight except one little front door. That's how the internet works. Your router keeps things locked to stay safe. But what if you want to let something specific inside, like a pizza delivery guy game server or your best friend remote desktop? That's where port forwarding comes in. Port forwarding is like telling the security guard at your gate, if someone knocks and says, "I'm here for pizza," send them straight to the kitchen. If they say, "I'm here for gaming," send them to the Xbox in the living room. Each door or port number is like a special code that decides which device inside your network gets the message. Without port forwarding, your poor pizza guy would just stand outside your gate yelling, "Who ordered pepperoni?" and nobody inside would hear him. With it, the request goes straight to the right device. Of course, you have to be careful. If you leave too many doors open, strangers might sneak in. So, port forwarding is like giving out just enough keys to trusted guests while keeping the weirdos locked out. And that's it, friends. You just unlocked the mysteries of networking without falling asleep in class. If you had fun learning, hit that subscribe button and join me for more easy, funny tech breakdowns.